Alright, so we're going to solve two proportions here. Yes, this is kind of fun to do. You kind of follow the same process and then you get an equation to solve. One of these is a simple proportion, this first one. Simple proportion, this is more of a complex proportion. So what is the difference between these two? You can kind of tell just by looking. If you have a plus or minus within your proportion, that just means we'll have a couple extra steps. We'll talk to it when we get to that example. But let's look at this first one. We have x over 4 equals 3 over 2. Anytime that you have one fraction equal to one fraction, you can do this great, wonderful trick called cross multiplying. So what cross multiplying does is it has you multiply your diagonals like this. Now, our goal of cross multiplying is to get out of the fractions, because the fractions are what make this kind of a trickier equation. So, x times 2 is a 2x. We always put the number in front of the variable. Now we're going to set it equal to the other one. So that's the key here. You're going to have one diagonal equal to the other diagonal. I think they call these cross products. So we're going to multiply 3 times 4 and we get 12. Now we have this nice equation. Sometimes you might have one or two steps to solve. This is just a nice little one step. So we're going to divide, well, we have 2x equals 12, so you go to where x is. It's being multiplied by the 2. So we'll do the opposite of that and divide both sides by 2. And we get x equals 6. So that's your simple proportion. We cross multiplied to get out of the fraction. Now the complex proportion, what is it that makes this complex again? Those addition and subtraction signs. Just means we might have a couple extra steps, but you still follow the same basic concept of cross multiplying. I'm going to multiply this diagonal. And one question that often comes up is, does it matter which diagonal you multiply first? And it does not. Because you end up with an equation, over here we could have said 12 equals 2x, and you solve, you would get the exact same answer. So it doesn't really matter which diagonal you multiply first. Now the thing here is we have to take this 5 and multiply it by that whole thing of x minus 1. So we are going to bring in parentheses. We're going to do 5 times, and we'll represent our multiplication with a parenthesis, x minus 1. And that's showing that 5 is being multiplied by the whole thing. So if you have a plus or minus in your proportion, bring in those parentheses. Then multiply the other diagonal. Remember to set it equal to each other. 3 times that whole thing of x plus 1. And now we have an equation to solve. So when you solve an equation that has parentheses, remember we are going to distribute. So we're going to multiply the 5 times the x, which is 5x, and then let's multiply the 5 times this 1, and really make sure you pay attention to that sign. It is a negative 1. 5 times a negative 1 is a negative 5. Bring down your equal sign. Let's distribute the 3. 3 times x is 3x. 3 times 1 is 3. And it was a positive 1 and a positive 3, so that's why that's a positive 3. So now when we solve, you've got variables on both sides, so let's get those together. Sometimes I like to move the smallest one. We have a positive 3x on the right, so we can go ahead and subtract 3x from both sides. 3x minus 3x cancels. This leaves us with 5x minus 3x is 2x, minus 5 equals 3. And now we have a two-step equation. To solve this, we have to get that 5 to the other side, so we'll go ahead and add 5. So we have 2x equals 8, and then 2 times x, last step is divide by 2. 8 divided by 2 is 4, so we have x equals 4. And that's how you solve a complex proportion.